Welcome back, guys, to the next set of lecture notes. Today is all about talking about atoms, those teeny tiny little elemental particles that make up everything else in the rest of the universe. We're going to be talking a little bit about how we classify atoms, but mostly what is their structure and how can we figure it out based on looking at something called the periodic table. So let's go ahead and get started. So atoms and the periodic table is what we're really going to be focusing in on today. What are atoms? What are the little parts that make up atoms? And how can we figure out how many of each part that an atom has? So this big guy right here is called the periodic table. And every single one of these little boxes is an individual atom. So each one of these boxes represents a different atom that exists in the universe that scientists have been able to identify and classify. We'll talk a little bit more about exactly how the periodic table is organized later on. So for now, just know that each one of these boxes is an atom, and each individual atom has different properties that separate it out from the other atoms on the table. And we'll talk about exactly what those are in just a second. So, atoms. These are the smallest unit of matter in the universe. So everything else in the universe, planets, stars, plants, humans, animals, rocks, water, air, it's all made out of atoms. So there's over 100 different atoms that scientists have recognized, and all of them contribute in some way to the world and the universe that's around us. So atoms themselves are made up of these smaller building blocks that give them their different properties. So we have protons, we have neutrons, and we have electrons. So this is just kind of a basic kind of cartoon image of what an atom looks like. Atoms are so tiny that it's almost impossible to see individual atoms, even with the most incredibly powerful microscopes that humans have been able to build so far. But we've been able to figure out some kind of specific characteristics that all atoms share in common. So as you might be able to notice, for our three different particles here, 1, 2, and 3, protons, neutrons, and electrons, there are kind of two different places where we can find them. We can either find them in the middle part of the atom, or we can find them kind of orbiting around on these rings on the outside. So kind of swirling all around on the outside. And so two of our particles are in the middle, and one of them, the electrons, is swirling around the outside. So that middle part of the atom has a specific name. It is called the nucleus. So the nucleus is the center of the atom, this kind of little ball of little guys all smushed up here in the middle. That is our nucleus. It's responsible for the vast majority of the atom's mass. So mass is similar to weight. So the amount of mass that an atom has is pretty much entirely made up of the stuff that's in the nucleus. So inside of our nucleus, we have two of the three major particles. We've got our protons, which are these little red guys right here. And we've got our neutrons, which are the little blue guys. So the protons and the neutrons are together in the nucleus, and then those electrons are the little green guys that are all orbiting around on the outside. So we're going to go through these three different particles one by one, protons, neutrons, and electrons, and talk a little bit more about each one of them. So protons are here in the nucleus. They're 1/2 of what's going on, the different particles in the nucleus. And protons, the important thing to remember about them for right now is that they have a positive charge. So just like the battery in your car has positive and negative terminals on it, atoms have positive, neutral, and negative areas in them as well. So the protons are what's responsible for the positive charge in an atom. And so this one is pretty easy to remember because P is for proton and P is for positive. So protons are positive and they exist as part of the nucleus. So they are in this big bundle of particles right here in the middle. So protons in the nucleus, positively charged. Then we have our neutrons. They are also part of the nucleus. So they and the protons are hanging out down here in our nucleus together. Neutrons, unlike the protons, however, do not have a charge. So they have, some people call it a zero charge, or where they get their name from is having a neutral charge. So it's not positive, it's not negative, it's neutral. So this one can be a little bit tricky because people are tempted to think that, oh, N is for neutron, N is negative. That's not actually the case. It's actually that neutron, so this NEU right here, neutrons are neutral. So they do not have a charge on them. The neutrons are neutral, or like a zero charge, not a plus, not a minus, a zero. So our atomic mass, or the weight of the atom, is calculated by adding up the protons and the neutrons. So our nucleus here in the middle right here is the weight of the atom. So we take the protons and we add them to the neutrons, and those together make our atomic mass. All right, make sure to remember this because this is going to be important in just a second. So in the nucleus, we've got protons and we've got neutrons. The protons are positive charges and the neutrons are neutral charges. They don't have a charge, they're zero charge on those guys. Add them together, we get the mass of the atom. So finally, our third particle is our electrons. These guys are not in the nucleus. Instead, they orbit around the nucleus. So they are not in the nucleus, right? This little area down here, no electrons in there. Instead, they are on these little orbits that go around the nucleus. So they're kind of zooming all around the outside of the nucleus, just like the moon goes around the Earth. These electrons are zooming around the nucleus of the atom. So the electrons are where the negative charge comes in. So electrons are negatively charged. Sometimes we'll see them written as like a little E with a negative sign on it, meaning a negatively charged electrons. So these ones, people always get confused between the electrons and the neutrons because they think, oh, neutrons are negative, so electrons must be neutral. That's not the case. Electrons are the ones that are negative. So as you may be able to guess, electrons are where electricity comes from. So electricity that powers our lights and our washing machines and our AC units, those come from electrons flowing through a specific area. So I try to think of it as if you get electrocuted or if you get electricity you're going to have a negative time in your body. It's going to hurt. It's not going to be fun. So electricity is negative. Electrons are negative. They're not in the nucleus. They're zooming around all over the outside. So even though atoms are super, 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 duper, duper, teeny, teeny, tiny, protons or neutrons are even more super, duper, teenier and tinier. And electrons are even more incredibly small. So the electrons are so small and so light that they're not really counted in terms of the mass of the atoms. We really only focus in on the protons and the neutrons for mass. The electrons are so light, it's like air. It's like nothing there. Just these tiny little negative charges that are zooming all around our atom. So we've got protons and neutrons in the middle in this nucleus area. The protons are positive, the neutrons are neutral. Add them together and we get the mass of the atom. Electrons orbiting all around the outside of our atom, they have a negative charge, so electricity is negative, electrons are negative, and they do not count towards the weight of the atom. They're so tiny and small and light that we just don't even pretend like they're there. All right, so now that we know a little bit about how each atom is structured, let's figure out how can we tell different atoms apart from each other. What is the information that will tell us how atoms are distinguished from each other? Luckily for us, all of that information is contained within their little box on the periodic table. So every single atom, all 112 to 118, depending on who you go by, has a box on the periodic table. And usually, inside this box, it will show 4 pieces of information. We've got the name of the atom right here. So in this case, krypton is our little box on the periodic table that we're looking at. We've got the symbol of the atom right here. So whenever like a scientist or a chemist wants to write down the atom, but is writing lots and lots of them, so just wants to give them a little symbol, they'll use this symbol on the periodic table. So krypton is Kr, oxygen is O, carbon is C. The symbol is just a shorter way of writing out our atom, our element. So we've got our name and our symbol. We then have 2 numbers on our periodic table box. We've got a smaller number, usually written at the top of the box, and a larger number, usually written down here at the bottom of the box. The top number is the atomic number, and the bottom number is the atomic mass. Every single atom on the periodic table has a different atomic number and a different atomic mass. So for krypton, our atomic number is 36 and our atomic mass is 83.8. A lot of times when we're doing calculations with the atomic mass, we'll just kind of round to the closest whole number so that we don't have to deal with these smaller kind of fractions. And so we could also say that krypton has an atomic mass of 84, because 83.8 is almost 84, so we can round up as well. So an atomic mass of about 84 and an atomic number of 36. Each one of these numbers tells us something about the atom. So let's go through them one by one and figure out what we can determine about an atom from its atomic number and its atomic mass, or its atomic weight. So the atomic number, that little number up at the top of the periodic table box, is the number of protons that are present in that atom. So every single element on the periodic table, every single atom has a different number of protons. And we can determine which atom that we're looking at by figuring out the number of protons, and that will tell us the atom that we have. And so on our periodic table, it's arranged in order from smallest atomic number to largest atomic number. So krypton is number 36. So it has 36 protons in this atom. And it's going to occur relatively high up, relatively early on in the periodic table, about a third of the way through or so. So every element is defined by how many protons that it has. Every single atom that you find out in nature that has 36 protons is going to be a krypton atom, every single time. So this is how we organize that periodic table, is we just figure out the number of protons and then put it in up next. So we go from the smallest number is up in the top left of the periodic table, largest number is down in the bottom right. And then we just fill in all the rest of the atoms in between. So atomic number gives us the identity, and more importantly, tells us the number of protons. All right, so this bottom number down here is our atomic weight, or the atomic mass. So it gives us the approximate mass of one atom of an element in what's called atomic mass units. So atoms are so incredibly teeny tiny, we can't weigh them with normal ways of measuring, like pounds or grams or ounces or anything like that, because every single measurement would be like 0.00000000000000123 grams. And nobody wants to write that every single time. So instead, scientists came up with a new measurement, AMUs, that tells us about how much one atom weighs. So they figured out how much to weigh an AMU by essentially just saying, all right, we're going to say that protons are 1 AMU and neutrons are 1 AMU. So, like I mentioned before, if we add up the protons and the neutrons, we should be able to get our atomic weight. Now, usually it'll be a whole number with a little decimal, so like 83.8, 12.99, 15.966, something like that. And that's because when scientists really go into weigh these, they use these super technical and precise measurements of weight. We're not really going to worry about that. Like I said earlier, we're just going to kind of round our atomic weights to the nearest whole number. So if we had 83.8, it would go to 84. If we had something that was like 12.15, we would round it to just 12. All right, so this bottom number, this atomic weight, tells us how much the atom weighs. Now, if you remember earlier, the atomic weight is the protons plus the neutrons. So if we know the atomic weight and we know the atomic number, which we always will because those are the two numbers that they give us, not only can we know how many protons are in an atom, but we can also figure out how many neutrons are in an atom just by looking at this box on the periodic table. So let's see how we'd figure that out. So we want to calculate how many neutrons an atom has. We know that the atomic number of the atom, so that small number up in the top box, is the protons. And I mentioned earlier that the atomic weight is if we add up the protons and the neutrons together. So those two together give us the atomic weight. So that means that if we take the atomic weight and we subtract out the number of protons, or the atomic number, that will give us the number of neutrons. So the atomic weight minus the number of protons will give us the number of neutrons. Because remember, if we have the atomic weight, that's protons and neutrons combined, and we take away the protons, we minus them, that means that we have the neutrons left over. So if we do the weight minus the number, it'll tell us how many neutrons are in each atom. So let's look at krypton, the example that we were just looking at the other slide. Krypton has an atomic number of 36 and an atomic weight of about, we'll say, 84. So we want to figure out how many protons that krypton has. That's easy. We can just take the atomic number, which is 36. So krypton has 36 protons. If we want to figure out how many neutrons that krypton has, well, we know the weight, we know the number, and so if we do the atomic weight, or mass, minus the atomic number of 36, 84 minus 36 equals 48. So krypton has 48 neutrons and 36 protons. This is what is present in the nucleus of krypton. 36 protons and 40, excuse me. See, look, so many numbers going on. 36 protons and 48 neutrons, put them together, and we get 84 as the atomic weight for krypton. So if we ever want to figure out protons and neutrons of an atom, it's really easy. Protons is just the atomic number, and neutrons is just the weight minus the number. That's how we calculate the number of neutrons that are in an atom, just based on its little square of information on the periodic table. But we still have one more little particle that we haven't talked about calculating yet, and that is our electrons. So we know that our protons and our neutrons are hanging out in the nucleus, but our electrons are zooming all around outside. So how do we figure out how many electrons are in a single atom? Luckily, it is really easy. So for the most part, the atoms that we talk about in this class have what's called a neutral charge, meaning that the positive and negative charges on the atom are balanced. So positive and negative are balanced. So if you remember, our protons are our positive charges and the electrons are our negative charges. So in a neutral atom and a balanced atom, our positive charges have to equal our negative charges in order to have that balanced neutral charge, which means that neutral atoms will always have the same number of protons and electrons. So the proton number and the electron number will always be even in these neutral atoms. So the most simple example out there is hydrogen. Hydrogen is the very first element on the periodic table. It has an atomic number of 1, and it has one single proton in its nucleus. It doesn't even have a neutron, just one proton in its nucleus. So, since hydrogen has one proton, what does it need in order to be balanced? It needs one negative charge, and so it has to have one electron. So in our neutral atoms that we're going to be talking about in this class, we have to have equal numbers of protons and electrons. So our atomic number, if you remember from just a second ago, our atomic number not only does it equal our number of protons, but it is also equal to the number of electrons. So the atomic number, the number of protons, and the number of electrons should always be the same. All right, now I want you to try and figure out how many electrons does carbon have. I'll give you a few seconds to think about it, and then we'll walk through it. So remember, the atomic number is the number of protons, and the number of protons is the number of electrons. All right, so if our atomic number of carbon is 6, then that means that carbon has 6 protons, or 6 positive charges, which means that carbon must also have 6 electrons, or 6 negative charges. So carbon has 6 electrons all zooming around on the outside of the nucleus. And that should be everything that you need to know for our first set of notes in dealing with atoms and the periodic table. So the worksheet that you guys are going to work on for this is going to have you doing a lot of figuring out how many protons, how many neutrons, and how many electrons are in a specific atom. So let's take a look at what the worksheet looks like. There we go. So the first part of the worksheet up here is just kind of a review of some of the stuff that we talked about already in terms of atomic weights, protons, neutrons, and electrons, stuff like that. So for the first part of this worksheet, we have this little element down here, this little atom, and you have to figure out how many protons, how many neutrons, and how many electrons are in this carbon atom. So we have a little cartoon carbon atom down here, and based on what we've learned, you should be able to pretty easily figure out the number of protons, neutrons, and electrons. Up next is another little section of notes that talks about how we recognize different parts of an atom in a periodic table. So remember that in each box, we have the element name, so the full written out name of the element, in this case, helium, the chemical symbol of the element, so the 1 or 2 letter symbol that represents that element. The atomic number is the smaller number that's up on the top, and the mass number, or the atomic mass, or the atomic weight, is the larger number that's down here on the bottom. So for this little example of helium right here, the first thing you're going to do is figure out how many protons are in helium and how many electrons are in helium based on the fact that it has an atomic number of 2. And then helium has an official mass number of 4.002602, but that's really close to 4, so we can just round that down to 4. So helium has a rounded mass number of 4. So using that information and the information about the atomic number, you should then be able to figure out how many neutrons are in one atom of helium. So that's kind of the second part, protons, electrons, and neutrons for a helium atom. And then finally, the last part and kind of the main part of the worksheet is we have 6 elements represented down on this bottom part. And for each element, you should be able to tell me how many protons, how many neutrons, and how many electrons are in each one of these elements. So for each element, you'll have like a little P, an N, and an E, and you're going to want to write down how many protons, how many neutrons, and how many electrons are in each atom. All right, so 3 parts. Protons, neutrons, electrons in this little cartoon of carbon. Protons, electrons, and neutrons in this helium example. And then finally, protons, neutrons, and electrons for each one of these 6 atoms down here. Hopefully, all that information is helpful to you guys. This is one of my favorite parts of IPC, kind of digging into and doing a little bit of problem solving on each one of these atoms and learning about how much information we can get just from that little box on the periodic table. As always, please reach out to me if you have any questions. You can send me an email, you can text my work number, or you can come to the Zoom office hours or write down your question on the assignment on Google Classroom. Once you are done with the assignment and ready to turn it in, remember that you can take a picture of it or submit it directly to the Google Classroom, or you can text a picture of it to my work number or send an email of your work to my email. Again, please reach out if you have any questions, but that'll be it for now, and I'll see you for our next set of lectures next time.